inverses of functions. So think of a function as a process. Consider the function f of x equals 3x plus 4. When you plug in a value for x, what are the steps that you follow to find y? So we would plug in some number for x. If you want, you can think of a number to plug in, like 1 or something. 3 times 1 plus 4. So what do we do first? We plug in a number, and what do we do with that number first? Yeah, so what's the first one that we're going to do? Yeah, so we multiply 3 first. Then what? Then we add 4. Okay, what would be the opposite of that process? Yes, but because we're doing the opposite, we're actually going in the opposite order.
So we minus 3, minus 4.
Subtract 4 first, yeah. And then divide 3. Would that be the opposite? So what that would do for us is it would allow us to take the y value that we get out and go backwards to find the x value that we started with, right?
Does that make it a fraction?
It might likely make it a fraction. Let's do it. So if this was our original function, f of x equals 3x plus 4, our inverse function, we're going to learn this, but I'm going to go ahead and show it to you now. Inverse, we just do a little negative 1 power to indicate inverse. So the inverse function would be following these steps. So we're going to take a variable. So I use x, so we'll just use x. And what are we doing first to that? Subtracting 4. And then after we subtract 4, so that whole process, x minus 4, then we do the last step, which is divide by 3. So this function is the inverse of the original. And the purpose of an inverse is to undo what the other one does. Like I said, we can plug a number in for x to get our y value. What if we want to reverse that process? We plug in the y value, even though I'm calling it x, it would basically be the y value that you got out to begin with. Plug it in, and you should get the x value you started with back out. It's always good to have something that undoes stuff, right? That's how we solve things, by going backwards. All right. So, inverse functions. Are you guys good on this part? Perfect. Here's our definition. Function g is the inverse of function f if f composite g of x equals x, and these both have to be true. G composite f of x also equals x. In other words, if we take a value, we put it through a function, and we take that answer and put it through another function, and we get what we started with, then they could be inverses. And then if we do that again the other direction, and it turns out the same again, then it's definitely an inverse. It's reversible either way. Okay? So we call this invertible, and they are inverses of each other. So example 1, we are going to verify that the functions f of x equals 1 over x plus 2 and g of x equals 1 over x minus 2. I should have said 1 over x and then minus 2, whereas this one, the x plus 2, is all in the denominator. We want to verify that those are inverses of each other. So we're going to do f composite g of x. What does that mean we're going to do from last time? G plugs into f, yes. So we're going to go 1 over x minus 2. So that's g plugged into the x value in f. and then subtract 2. Wait, that should be a plus 2. Getting lost. So I'm taking this. I'm trying to change colors, I think, and it's not. We're taking this and we're plugging it into that x value right there, and we get this, correct? Okay, let's go ahead and simplify. So even though I put that in parentheses to indicate that was g that I was plugging into f, are those parentheses really necessary? No. So we can go ahead and do the minus 2 plus 2, right? So that just takes it to 0 there. And then if we're taking 1 over dividing by 1 over x, that means the same thing as doing 1 times x over 1, which is just x. Huh. So plugging g into f, end up with just x. Yeah, so far this looks like it could be an inverse. So check, that one worked. Let's do the next one. So g composite f of x means we're going to plug this term, we're going to do this whole thing right here and put that right there. Okay, so we'll have 1 over x plus 2, and then we have a minus 2 out here. Okay, I'm going to ignore the minus 2 for a minute, and I'm going to go ahead and do my division of fractions, which means I'm just going to flip the second fraction, the bottom fraction over, and multiply instead. See what I did there? I just took, so 1 divided by 1 over x plus 2, so that instead of dividing, I can go 1 times x plus 2 over 1, right? Then subtract 2. Well, that, I don't know if I even need to write this out, because I think it's pretty obvious that those 1s don't do anything. So then we have x plus 2 minus 2, which is just final x. They work together. So these are in fact inverses of each other, which should make sense, because one has a minus 2 and one has a plus 2. But they're kind of in different places in the column, because the order is reversed as well. Okay, I think I'm going to